Hey guys, my name is Shahab and welcome to my channel. This is another episode of Inside Out about Roslyn, and in this episode we want to talk about code analyzers. Roslyn analyzers are inspecting your C# code for something like code quality or code design or maintainability, style, etc. And we could also write our own code analyzers for a specific scenario that we have in hand in our projects. In this episode, we want to see how we could implement a code analyzer and how we could integrate that into the compiler pipeline. They are going hand in hand with the diagnostic API to report any issues that we are finding. So let's dig into it. Today we want to analyze our code, and the problem that we want to analyze and provide like some suggestions and some diagnostics to the API is about this problem that I've seen a lot in some of the projects that I've worked with, that we have people that are throwing an exception in scenarios that the method is returning something like the maybe of t or an optional. This is like a type borrowed from the functional programming in the object-oriented world, like to avoid null, or there's also another similar pattern like the result pattern. And I've also seen people, instead of returning result.error or something like that, they are throwing an exception. And now in this session, we want to write a code analyzer, which is actually a semantic analyzer. We will discuss what is a semantic analyzer, what is a syntax analyzer momentarily. But today we are writing a semantic analyzer that wants to analyze if we have a throw exception somewhere in our code, but the return value of the method is something like this type of maybe, then we want to warn or inform the user about this is something wrong, and maybe you want to consider using maybe.none, right? I have already created a sample.analyzer project. This is nothing more than just a class library, but there are a couple of properties that we need to make sure that they are set properly. So the first one is the target framework needs to be net standard 2.0, and we should also make sure that it is a Roslyn component. And a couple of NuGet packages need to be referenced. The most important ones are these two in here, which are Microsoft.codeanalysis.c# and Microsoft.codeanalysis.c#.workspaces. So by having all of those things, we could go and implement our code analyzer. If you're using JetBrains Writer, you could right-click there and say Add New Project, and there's a template called Roslyn, and then you could provide a name, and it creates a Roslyn Analyzer or a Roslyn source generator, depending on what you want to do. If you're using Visual Studio, there's also other templates available in Visual Studio that you could use them to create your source analyzers and source generators. Back to our code, let's copy this piece of code that we have in here and go to sharplab.io and analyze how we could detect this anomaly in our source code. Here we are in sharplab, and what we want to do is that we want to find these through statements in our syntax tree and then navigate the syntax tree up to where the method declaration exists. And then we want to grab the return type value of the method and analyze whether it's a maybe that we are looking for, or is it some other types that maybe have the same type name as what we are writing in here. You could see that this through statement has an equivalent in the tree in here, and it has an operation of type throw. Now let's go back to code and see how we could access that. In our project sample.analyzers, we have a maybe semantic analyzer class. There are a couple of things with this class that are important to mention. The first thing is that it is inheriting from the diagnostic analyzer class. The second thing is that we need to mark them which languages they are supporting, whether it is a C# or Visual Basic. And another important information is their ID. The ID is the unique identifier of these analyzers, and later on, if we are providing any code fix for these analyzers, we could link them together. The next thing that is important is defining a diagnostic descriptor for this diagnostic using the information that we have above. So we could provide the diagnostic ID, we could provide a title, some category, whether it's a usage category, whether it's a design category or something else. And another important thing is that what is the default diagnostic severity for this analyzer that we are creating? The next step is to override the initialize method on the semantic analyzer and then register an action for them. Here we are registering an operation action. The operation action is helping us to subscribe to a semantic at compile time and for an action invocation. If we go back to SharpLab and see, if we go back to SharpLab, we will see that this throw statement that we had, it has an operation kind of throw, and that's why we have this operation kind throw in here. Let me show you on the SharpLab. So here is our throw statements, and you will see that its operation is of type throw. That's why we have registered for this kind in our source analyzer. The first thing that I'm always doing when I'm creating a source generator or a source analyzer is just checking that whether the cancellation token is already requested or not, and throwing it. Because I don't, if it is already requested to cancel the build operation or the compile operation, why should I continue doing any analysis, right? So this is where we want to stop. Another thing that I want to have is some guard clauses, just to making sure that the context of operation, if it is not of type throw, we are not interested in continuing. And also if the syntax node that we are running this analysis on that is not of type throw statement, then we are not willing to continue because it's not about our scenario. Another thing is that we want to make sure that the semantic model is initialized and populated in our scenario, so we have access to those information because this is a semantic analysis. Context.operation is not I throw operation, right? And or context.operation.syntax is not throw a statement syntax, then we are not willing to continue. And also if context.operation.semantic model is null, then it means that we don't have enough information to further analyze the things. Now that we know that the node that we want to run the analysis is the correct one, what we need to know is going up the syntax tree and returning to the level that there is a method declaration. So we need to get the containing method of this throw statement and then extracting its return value in here. So where containing method syntax would be get containing method. We will implement that momentarily, and we are passing the syntax node that we have in here, right? I think I have some typo. Then we need the semantic model of this method declaration syntax, and we could get it via the context.operation.semantic model that get declared symbol. Let's just rename the variable containing method symbol. And everything that is a declaration syntax, I don't know, method declaration syntax, class declaration syntax, all of them, we could access their semantic model using the context operation semantic model and then using the get declared symbol. Now that we have access to the symbol API of the method, we could get its return type to analyze further to see whether this return type is the actual type that we are looking for or not. So let's access that return type, and it would be containing method symbol.return type. And then we need to have access to the maybe type that we have defined in our code, and this maybe type, we also need its semantic, because if we want to just compare the syntax of those things, it could happen that there is another class called maybe, but in a different package or namespace, and it's just similarities in the name. We don't want that. We want to make sure that this is exactly the type that we are looking for. And for that, we could achieve it by using the context.compilation dot get type metadata by name. And here we are passing the fully qualified name of the class. And since it is a generic, we need to specify this part in here like this. Now that we have access to both the return type and the actual type that we expected to compare to, we want to compare these to each other. If the semantic model of those two are not the same, then it's not what we are looking for and we could just return. If it is the same, then we want to report a diagnostic to the diagnostic API so the user could be informed about this warning or information or error that we are deciding to have. Let's do that. If return type dot original definition, I will describe why I need this original definition on code later on. Let's just continue for now. If it is equal to this maybe type and we need to provide a comparer, so we just provide this default comparer. If they are not the same, then we return. If they are the same, then we are creating a diagnostic. We need to put the squiggles or highlight the diagnostic for the whole statement. So we need to get the location of that node. Diagnostic dot create. First we pass the rule that we have defined, the descriptor, and then we are getting the location that about that syntax node that we are analyzing in here. After that, we just say context.report diagnostic. We are kind of done. We have a couple of things to mention. First, we need to implement this getContaining method and also defining why we are using the original definition and we are not just directly comparing return type and the maybe type together. Let's implement this first. Create method. What we are expecting as a result is a method declaration syntax, and the input parameter is a syntax node. We just name it a syntax. So what we want to do is we want to just traverse the tree until we are getting to a point that the parent of this tree is a method declaration, because a throw statement could be inside an if statement, could be inside a try catch block, could be inside anything. As far as we are achieving somewhere that the parent is method declaration, we are fine to stop. So if the syntax dot parent is method declaration syntax, then we are returning that one. Otherwise, we are just returning, replacing that with its parent. And since we know in this tree the parent is not null, I'm just putting this is not null there. To describe this original definition, let's go to our file that we had in here, the greeter. In here, you are seeing that this is a maybe of a string. And what the type that we want to compare it to is of type maybe of t. It is a generic type. So maybe of a string is not equal to a maybe of a generic thing. So that's why we need the original definition of this maybe of a string and compare it to the this generic one. That's why we need the original definition. The last thing is that in our console application, we want to add a reference to the analyzer project. To do so, we just add a normal project reference to our project, and then we mark that to have output item type of analyzer and a reference output assembly to false. These two values we are setting. So let's build our project and see how our analyzer is working. Cool. Now it's time to build this solution and then our other project. If we go now to the greeter class, you will see that we have a squiggle there and it says SHG001 use maybe.none instead of throw exception. And this is coming from our analyzer. If we run the build via the command line, we should get the similar experience. So I'm at the console application and I'm calling .NET build over my console application. And you will see that I'm also getting a warning in here with the same code and the same message in here. If we want, we could change the severity of our analyzer to not being warning but being an error. And now if we build the selected projects in here, you will see that we now have an error instead of a warning. And if we go to our greeter class, it is an error. That's it for this episode about code analyzers. In the next episode, we will discover how we could write unit tests for our code analyzers to make sure that if we are doing any refactoring or something, they will still work as expected. Thanks for watching. Please do not forget to like and subscribe and share it with your friends. And if you have any further suggestions, do not forget to leave comments below. Thanks, and as always, enjoy coding. دمتون گرم.